today we'll talk about analyzing unstructured data, and specifically text. But what are other types of unstructured data? I suppose if they're just out there and not in tables, they could be unstructured. But you typically think of accounting data as structured data because it's already in a database or something like that. Any other ideas? Okay, how about, no, I'm not giving you any hints. How about images? Do images contain data? Yeah, they do. Now that I've given you another hint, I mean, what else? How about videos? How about audio? Data that's in a table. It's already got field names, and they're already predefined, and there's already data there. So for example, if you scan an item when you check out, then there's data that's already thrown into a table. You know, there's transactional data, right? But if you, on the other hand, if you go to a book and you see all these words that have meaning, it's not structured. It's not ready for analysis. Okay. So because of the internet and because it's so easy to get your hands on so much text, right? Now people have come up with ways to analyze that text. You know, it's always been possible since programming basically was, since computer scientists, you know, emerged. It's always been possible to analyze text, but now it's much more common, and there are methods that make it very useful. Okay? So let's take a look at what is called text mining and text analytics, sort of synonymous. So what is text analytics? Well, it's the extraction of information from text and the analysis of that information. And you use computers to do it. And computers are great because you can work with very large data sets, and you can perform algorithms that would take humans forever to do, right? So this graphic comes from a book called Practical Text Mining and Statistical Analysis for Non-Structured Text Data Applications. And it says, well, there's this domain called text analytics, but there are many areas. For example, there is this idea of information retrieval. And information retrieval is something you guys use every day when you do Google searches, right? So Google takes your input string and matches it to these web pages that have been indexed, and you get instantaneous results. So information retrieval can be very good, like Google, or it can be very primitive. You know, there were old web browser search engines. What's an old search engine you used to use? What's it called? Hotbot? I never used that one. Alta Vista? Ask Jeeves? Any of you use web crawler? That's a pretty old one. Okay. So how about this classification? So this is the area of text analytics that would include our naive Bayes problem that we worked on last time, where you're classifying tweets as, either related to the app, the Mandrill app we looked at, or related to something else. So document classification. Also clustering, okay? So we did a clustering exercise, but we didn't use documents, but you can classify documents based on similarity, and so on. So there are many areas of text analytics. So there's this idea of structured versus unstructured data. And unstructured data refers to information that either does not have a predefined data model or it's not organized in a predefined manner, okay? So it's not put into tables with predefined columns that have meaning. All right, so this results in irregularities and ambiguities that make it difficult to understand using traditional computer programs. All right, so there's this idea, and this was almost 20 years ago now. Merrill Lynch said that somewhere around 80 to 90% of possible usable business data is unstructured. So it makes it important for us to try and access this information. So by analyzing unstructured data, you're trying to get a competitive advantage. You're trying to get ahead of the game, okay? You want to understand market trends and reactions before anyone else does. You want to detect fraud. You want to be able to predict the future, understand consumer preferences, and so on. Of course, this is a very complex task. Not enough of us are out there that are able to extract information from unstructured data. So I'm trying to today pass some of this on to you guys, some of the ideas. And since you are now VBA programmers, and since you've done this, you parsed tweets, you tokenized them, you got the words and you counted the words. That's basic natural language processing. That's basic text analytics. So you guys kind of know what's going on already, right? So you've noticed even in those tweets there are some problems. So for example, there are a lot of different words. So we had thousands. How many different words were there? 2,000, 1,000 different words in just 150 tweets. Well, think about large documents. There could be over 100,000 different words if you have a large enough set of documents, and that could cause, some issues in your analysis. There can be word ambiguities. Okay, so what is the meaning of the word war, for example? Does it always mean invasion, or is there a war on drugs? Are we invading someone, or are you using the word war in sort of a metaphorical sense to describe what you're doing as a business? The word depression is a mental state. I'm sure we've all felt depressed at times, but maybe at the same time we were doing very well monetarily. So depression has different meanings. So sometimes there's noisy data, and you can see this in some of those tweets. There are typos, and when you really want to count words as the same, you can't because they're spelled differently. Okay. So how do you do textual analysis? Well, I came up with 3 steps, like I like to do, right? And it's these 3 steps make it so even a child could do a textual analysis. So the first step, select the data you want to analyze. Second, prepare the data. Third, analyze the data. So how do you select data for textual analysis? Well, first you have to think about what question do I want to answer. So what if I want to ask this question? What is management attitude toward the future? What new risks is the company facing? Well, how could I possibly use text to answer those questions? Well, maybe I can look at financial reports, okay? The MD&A section, for example. I can analyze the tone of the company or what management says in the MD&A and figure out what their attitude is toward the future, right? Or maybe I have access to emails. Maybe I'm working within a company and I can look at emails and gauge what management is thinking, what the employees are thinking, what they're saying. You could look at interviews, and you could even look at contracts. Okay, I mean, wherever you have textual data, you can gather together and answer questions. So these are just 2 examples, but the number of questions you can ask are unlimited. So once you've decided what question you want to answer and which data set could answer that question, then you can think about preparing the data. So extracting the data, getting all the text. So let's say your textual information is in a website and all the text is embedded in HTML tags, right? So then it's very difficult to analyze text when all the text is stuck between tags and so on. Or what if your text is in a Word document and it's not easy to process Word documents compared to plain text. So you need to convert your data. Typically you convert it to some sort of plain text. Then you need to remove artifacts, right? So let's say there are headers, let's say there are footers, let's say there are tables, let's say there are page numbers, let's say you want to remove the stop words or the common words that have no meaning, like the, of, and, because, from, above, behind, okay? Prepositions in general. Let's say you need to prepare the data as much as possible get it ready for analysis. So then, I skipped analyze the data. Well, let's look at an example of how I analyze data after I prepared it, okay? So I wanted to do a little exercise where I was able to detect the changes in risk factors year over year. So you guys know that in the 10K, there's this item 1A, and item 1A is a section where companies can list all the risk factors they're facing. And in item 1A, you have maybe, let's say there are 15 risks, and each one has a main heading, and then there's a paragraph describing that risk, okay? So I want to see if within a company, there's a new risk from one year to the next. So I know that external auditors, when they're evaluating companies, they'll look at this section, and they'll manually read these sections to see if there are changes from one year to the next. Then I want to detect differences in risk factors between related companies. So let's say there's Microsoft, Apple, Google, or what's a different, let's say there's Boeing versus Airbus, okay? Maybe they should have the same risk profiles, but maybe they disclose different risks, and I want to know about it. So in the first example, I'm just comparing the changes in risks between 2 years within one company. So I'm looking at Microsoft, 2007 to 2008. So I'm looking at just the risk titles here, not the content of the risks. Remember I said each risk has a heading, and then there's a paragraph or two about that risk. I'm just looking at the heading. So here are some risk titles from 2007. Challenges to our business model may reduce our revenues and operating margins. We face intense competition. We may not be able to adequately protect our intellectual property rights. So these are kind of general. Who doesn't face intense competition? any company that's profitable will eventually face intense competition. So here are the 2008 risk titles. Now this is just a sample. And the titles didn't change much from 2007 to 2008. These three at least were the same. So I want to compare all risk titles. So are all the titles identical? So what I do is I take all the risk titles and I put them in separate text documents, okay? Like Notepad, plain text, right? So each document's like 10 words long, 5 to 20 words long. And what I do is I compare. Imagine you have two folders in your computer, one with all the risk titles from 2007, one with all the risk titles from 2008. And for each risk title in 2007, I compare it to each and every one in 2008 to see if it has a match, basically. And then I do that with all the risk titles to see if there's a match between the 2 years. So how do I do this comparison? Well, I found a matching algorithm written in Python, and it's pretty simple. All it does is this. It takes the sorted intersection of two tokenized strings and returns the matching ratio between the intersection and the shortest string. So what does that mean? It means basically it tokenizes the risk title, which means it turns the title into a list of words, then it sorts it alphabetically, okay? And then it takes a second risk title that you're comparing it to, turns it into a list of words, and sorts it alphabetically. I think it's sorted alphabetically. But anyway, then by comparing those two lists of words and seeing how many of the words match each other, it creates some ratio of how well the lists of words match. And it gives me some number between 0 and 1, or I can multiply it by 100 to show a percentage. All right, not important exactly how this works. So here are my results. So across the top, I have the risk titles from 2007. The name of the document, not the actual title. And across the side, I have the risk titles from 2008. And you can see for every title, it is compared to every other title from the other year. And if there is this is a heat map, and if there's a solid green cell, it means it's closer to 100. And 100 means there's a perfect match, okay? So as long as each title has 100, at least 100, it means it matches with another risk in the other year. So in this example, Title 2 in 2008 is the same as Title 1 in 2007. They're the exact same risk. But Title 2 doesn't really match with any other risk, which is fine. So the titles are basically identical because you can see they each have a match, right? But there is one title that has no match, Title 20 from 2008. So this is the only new risk that was added from 2007 to 2008. And this is the risk. We may experience outages and disruptions of our online services if we fail to maintain an adequate operations infrastructure. All right? So then I go and look at the content of the risk factors, okay? Not just the titles, but the actual content. And that's fine. Maybe the titles are the same, but everything's changed underneath. But that's not the case. So even though I'm performing a much more difficult test, since now the lists of word isn't just 5 to 20 words like the title of the risk, it's like, it could be 100 or 200 words. It's still the exact same words in many cases, and if not, you have 98%, 99% matching between the content of the risk titles from year to year. So they weren't updated that much. Okay? So yeah, that can be pretty useful. So if you're able to detect and just automatically create a tool that automatically identifies changes in the item 1A section of the 10K or changes in any section of the 10K, that would help auditors to understand the company and how it's changed from year to year. So now I want to see, well, are there similarities in the risks between different companies that are in pretty much the same industry? And you would think there would be. So in order to do this, I compare Adobe and McAfee. Okay, you've heard of these companies. And I want to compare the risks. So one of the things I did to prepare the data is this time I removed stop words. I didn't do it in the other data set. It wasn't necessary since it was the same company. But here I removed the stop words. And to get this to work, I couldn't use the same matching algorithm. They use a completely different set of words to describe the same risks, okay? So the matching algorithm always gave me really low scores. Even if I read it, I'm like, this is the same. But what I noticed afterwards was there's usually like one or two really important words that if they both have that word, then it's the same risk. So if I can weight those words as more important, then I think I could more accurately detect which risks are the same, even though they use much different set of words to describe them. So there is a nice weighting algorithm called TF-IDF, Term Frequency Inverse Document Frequency, which gives weight to important terms. So without worrying about the mathematics of it, this is how TF-IDF works conceptually. So let's say we want to let's say we're looking at the word Rutgers, okay? And there are many documents or web pages on the internet that have the word Rutgers, but not that many, okay? In fact, most web pages wouldn't have the word Rutgers, right? But some would. But we want to do a Google search, and we want to identify those web pages that are mostly about Rutgers. So if I type the word Rutgers in, I don't get the web page where it's a blog, a student blog, and they're writing about everything, and they're a student from Rutgers, so they mention Rutgers. I don't want that to be the top hit, right? I want the top hit to be the web page from Rutgers itself. Well, one way to make sure that happens is to weight the term Rutgers in a certain way. So term frequency. If the word Rutgers is there a lot, then it means it's a very important word for that web page. But for that web page, there are other words that are there a lot too, right? Like university, the, of, and. So shouldn't those also be important words for that web page because they're there a lot? Well, not really. That's why we have this other term, the inverse document frequency, which says if there's a word that's there a lot, yeah, it's important, like Rutgers. But if it's also present in a lot of different documents, it's actually less important. So the word the, of, and, even university become less important words because they are in a lot of different documents. They're common words, basically. But if you get an uncommon word like Rutgers, and it's in one page a lot of times, then it becomes a very important word for that website. You know that website is about Rutgers. At any rate, When I did a heat map comparison of Adobe and McAfee, and here I did not multiply by 100, I get very different scores than I did when comparing Microsoft titles to themselves, right? Well, I don't have any exact match, but I have some strong matches. See 0.703, 0.673, 0.873. And these strong matches exist because there are some words that are heavily weighted that exist in both documents, okay? So let's try to identify what those words are. First of all, there are some risks that McAfee used that Adobe didn't use. We don't need to read those. Okay, so here are two risks that are the same, all right? Even though they're worded quite differently. This was the strongest match I had. So Adobe says, adverse changes in general economic or political conditions in any of the major countries in which we do business could adversely affect our operating results. McAfee said, conditions and changes in the national, global, economic, and political environments may adversely affect our business and financial results. So what are the words that you think are the same that cause these two risks to be identified as similar? Political, yep. Economic conditions is adversely there, adversely and affect results. So there are a lot of important terms that match. So that's why I got such a high score. But what's nice is that as the score goes down, the results are still good. So here are two risks that are covered by, that matched well with one McAfee risk. So we may incur substantial costs enforcing or acquiring intellectual property rights and defending against third-party claims as a result of litigation or other proceedings. And then another one about not being able to protect intellectual property rights. We face numerous risks relating to the enforceability of our intellectual property rights and our use of third-party intellectual property, many of which could result in the loss of our intellectual property rights as well as other material adverse impacts and so on. So yeah, it worked. Here's another one. And the risks, the matching score keeps getting lower because there are fewer important terms that match, but the risks still mean almost the exact same thing, right? So risks related to distributors and okay. So yeah, I was pretty happy with the results here. So this is actually work that I did with another PhD student, and this was something I did on the side, but she's analyzing the risk factors and creating some sort of a risk profile. So let's say we know all the possible risks. Say there's 100 common risks, okay? And we can now take every single company and say, okay, with these 100 risks, here's the ones that they disclose, and here are the ones they don't disclose. And we can do some pretty interesting analyses. So we could do each company, how their risk profile changes over time, or how each company compares to others within their industry, and come up with some pretty interesting findings.